Hello, this is going to be an introductory video to our biology class. This is our Unit 1, which is scientific measurement, scientific design, scientific method, as well as characteristics of life. The way the school has actually decided to teach biology is we break it up in units. So this is going to be our Unit 1, our first section of Unit 1, which is talking about observation and data. So we're actually, how do we make observations and how do we use data to glean that information? So first thing is we got to figure out what observations are. Observations are any time you use your five senses to collect data. So you can smell it, see it, touch it, feel it. You can measure it with things. Basically it's like using your eyes to notice green or brown, using your hand to feel smooth or hard or smooth, to actually use your eyes to read things. And then there's an inference where we actually use past knowledge, background information to actually glean maybe something that's true or not true. And if you take a look at this, we've got a bench that's got a wet paint on it, which may actually tell me I shouldn't sit on this bench. It's got two supports, probably some supports that we can't see actually holding this wood or this plastic for the bench. It's got bricks, different colors, probably has material in between it, probably not mortar, probably sand. We got trees in the background, may have birds singing, so you're using your senses to glean that. And my inference, using background knowledge, I've seen enough of these wet paint signs. Somebody puts the sign on there and then actually doesn't come back to take the sign off, and I think this probably is not wet. So I sit down on it and it may be true where everything's fine, or it could actually be false and the paint is wet and now my clothes are too. If you take a look at this, we've got blacktop and we got not so blacktop, and if you know anything about it, probably this is smoother, which is why it's bouncing back more light. This is not as smooth. It actually is bouncing back light but in all different directions, not hitting your eye as much. So you may actually go and feel this. You could probably, if you're in the picture, smell tar and actually understand this is relatively new. Blacktop, where this one is not as smooth, it's probably got cracks and holes and not as new. And then I go over to this one and it's darker and it's smoother, shinier, and I may actually think this is new. If I did observations, I'd find out this was dry and nice sunny day. This is not dry, it's got water on it, and it's actually not the light bouncing off the blacktop, but bouncing off the water looking nice and shiny. So in that case, if I think these have the same age because they're the same color, same shininess, my inference would be wrong. So the next thing is they're going to show you four pictures, actually in three groups, to try to come up with observations. So if we look at that, we can observe they've got these little things on them. We can count those things. We can see the color. We can see it's got some shiny stuff. We can see it's sort of curved by what it does with light and how it gets out of focus over on this end. And we can also make an inference. We can say this is actually lizard skin, because these are the armor plates that are on the skin. But then we have to go, wait a minute, red lizards. So we can also make an inference and say that that is a strawberry, but we don't know for sure. Here's a puppy and a rug and a human and paper towels and wet paper towels, all of which are observations. And then our inference could be that the person actually dropped a glass of milk and they're trying to keep the puppy away from it as they clean it, or maybe you could think it was the puppy's urine and the puppy peed on the rug. That's an inference. Again, could be true, could be false. And then here's a critter. Looks like it's got light skin, pretty thin based, lizardy looking. It's got arms, it's got fingers. Looks like it's scampering across land. If we look at its face, it actually has eye spots, but it doesn't really have eyes. And then our inference, because of all of that, could actually be that it doesn't have eyes because it lives in a place that there is no light. Maybe this is a cave-dwelling lizard. Again, could be true or not true. Data. Data is any information we gather through these observations. It deals with color, size, number, temperature. It can be lots of different things, but basically it's collected from an experiment. We have two different types of data. We have qualitative. Qualitative means like the quality of things. Is it good or is it bad? These are descriptions using letters, words, like the color, the shape, the relative size. So this would be like red. Shape, it could be like heart-shaped. Relative size, that heart's smaller than that heart. And then we have quantitative, and this is a description now using numbers. How many? How big? So we actually figure out that that one is 3 times this size and 3 times this size. We now count that there are 12 hearts on here, even though it says it's 10. We now can figure out that the reds all look the same. We can see that it looks like it's got a picture of an ant carrying leaves. So some of these hearts are upside down, carried by ants. That's the difference between quality. Quality is just talking about words, and quantity talking about the numbers. And I'm going to ask the kids when I do this, I'm going to ask them about a $5 bill. Okay, measurements in units. We can do the length, we can do the volume, we can do the mass, we can do the temperature. What does length mean? Length is the distance between one point and another. What do we use them? We're going to use an SI system, the System International, and it's the metric system. We're going to be using the meter, and we can actually use kilometers, saying 1,000 of those, or centa being 100th, or milli being 1,000th, but the meter is the basic unit. And how are we going to measure it? We're going to use the metric ruler, or some ruler with the metric system. Volume is the amount of space something takes, and usually it's a area thing, length times width, or it can be a three-dimensional thing, length times width times height. It's just basically how much space something takes. What are we going to use to measure that? We're going to measure liter if we're talking about liquids. We're going to use the meter if we're talking about solids. This would probably be, if we're talking about volume of an engine, we talk about cubic cc's, cubic centimeters. We can also use metric if we're using larger things. So we're talking about the amount of biomass that an oak tree has. We're not going to use liquids. We're not going to use cubic centimeters. We'd use cubic meters of wood. And what do we use to measure that? Graduated cylinder, telling us how much liquid's there. You always read the meniscus, and if we were going to do this, we would use a meter stick. Mass is how much matter an object is. You can't say weight, because weight is gravity's effect on mass. Mass does not change. If I moved you to the moon, you would have the same amount of mass. It just wouldn't be pulled down as much, so you wouldn't weigh as much. It's measured in grams or kilograms, large things, small things. It could be micrograms too if it's really small. And what do you use there? You use either a digital scale or use a triple beam balance, and we're going to try both of those in class. Temperature, it's measuring how much heat. Unit, we use Celsius or Kelvin. These are in degrees. Kelvin does not have the degree symbol, it's just Kelvin, like 0 Kelvin would be absolute zero, where that's minus 212 degrees. Nope. 273 degrees, minus 273 degrees Celsius. And equipment, we're going to use a thermometer. Thermometer has a liquid in it. The liquid expands when it gets hotter, so it rises and shows you higher temperatures. It contracts if it's colder and goes down. They used to use mercury, which works really well, but mercury is a bad thing, so now we use red alcohol. Makes the thermometers a little bigger. Measurement, units and notes, metric system. We have kilo meaning 100, represented by a K, hecta, 1,000 for kilo, hecta for 100 with H, deca, tens, DK. We have the basic unit for meter, so we can have a kilometer, we could have a hectometer, we could have a decimeter, decameter. We can do the same thing, kiloliter, we can do kilogram, we can do decameter, decaliter, decagram. We also have deci, which is 1/10. We have centi, which is 100th, and milli, which is 1,000th. And we can have a decimeter, centimeter, millimeter, or we can actually have a centiliter or a milligram, or mix these and match these anywhere we go. The way it works is, as the unit gets bigger, the number gets smaller. And I don't want you to look at these things. What I do want you to look at is this picture. And you can imagine this is a gallon and this is a 12-ounce glass. As the unit gets bigger, like this gallon compared to the glass, the number is smaller. So how many glasses of milk can you get out of a gallon? Probably more than the 1 gallon. So if we look at this number, 327 milliliters, and we want to change it into liters because that number is too big and I don't want to imagine what 327 of those are, I'm going to keep that 327, except I'm going from milli all the way up to liter. So I'm going to go 1, 2, 3, and I'm going to move the decimal point, which is right there, making it from a small number to a larger unit. So my number is going to go smaller. So what I'm going to do is I'm going to move it from that 7, there's 1, 2, and 3, and now I'm going to end up with 0.327. Number's the same, I just moved the decimal, making it smaller by 3 denominations. Here's kilograms into milligrams, so I'm going from here all the way down, and as the unit gets smaller, the number is going to get bigger, and it gets bigger by 1, 2, 3, 4, 5, 6 zeros. So I'm going to take that thing, not moving it this way this time, I'm going to go this way, so I'm going to get 2 there, got to add 4 more zeros, and I'm going to get 1,960,000. Mass of the sun, huge number. Scientific notation, you can actually count those zeros and put that point between 9 and 1 and put that point there with 30 decimals. Or what you can do is you can actually use a different unit. So if kilogram isn't big enough, you can actually go to mega. And if you know anything about computers, we had kilobytes, megabytes, gigabytes. We're now at terabytes. Then we're going to be bigger and bigger, and these are the names of the new hard drives. I can't wait till we get to a Yoda drive. That's actually, instead of saying to the 12, that's 12 more zeros, so exponentially bigger than that. So if I changed it from there, if I go from kilo to Yoda, what we can actually do is change that number from this huge number down to 190,900 Yoda grams, and that's the sun. And believe it or not, there are bigger, more massive suns. We're also going to use graphs. Graph is a pictorial way of actually showing your data. It shows the amount of something over a specific time. We use a bar graph. So if I was going to measure males and females, which we are going to do in class, we would use a bar graph because the males and females are not the same day to day and they're not the same class to class. If we have something that's actually over a period of time, we use a line graph, like this exponential growth of humans. We take the numbers for every year, or every 6 months, or every day, or whatever we want to do, and we put dots and we put a line on it. If we just wanted to measure males and females, we'd have to use a bar graph. So some of these are male and some of those are female. X-axis, and actually the way it works is bar graphs are non-contiguous data. The data has nothing to do with one another, like males and females, or ostriches and lions. Because as the ostrich number goes up, the lion number will go up also, but probably not as quick. And the same thing as the ostrich number goes down, because lions are going up, lions will go down, but again, but not by the same number. The ratio may be the same, but the number's not, so use a bar graph. If we were going to actually show the population of ostriches over time, we can use them because the data is the same. X-axis is always the one down at the bottom, and this is where we actually put the independent variable. And I like to think of the independent variable as what you knew before you did the experiment. You knew there were going to be lions and ostriches. That's where you would put that data. The dependent variable is what happens to the number you don't know. That's the thing you measured during the experiment. By. I didn't type this up, but it's manipulated by the experimenter. So I'm going to actually manipulate the amounts of lions and ostriches, and then this is how we actually measure it. We watch how the distance changes. And that's a stop. That means that I am done with this first part of Unit 1. So, bye.